When you start a break-even analysis question, what you need to do is determine a cost and a revenue equation. Now, I usually start with the revenue equation because generally speaking it's easier. Now, let's have a look here. The revenue is how much money he gets from selling the tables. Now, it's important to realise the difference between revenue and profit. Revenue isn't profit. Revenue is all the money that he gets back in before he's allowed for expenses. Now, if you read through here, it says he hires a workshop costing $200. Each table costs $50 in materials but can be sold for $120. And it's that what he sells it for that's important in a revenue equation. He sells them for $120 each. So all in all, the money he's going to make is going to be $120 times by the number of coffee tables that he makes. If he makes X coffee tables, the amount of revenue he'll get is 120 times X. It's probably a good idea to think of it. A good way of thinking about this is in a data table, because we're going to do it anyway when we draw our graph. So if, for example, Jack makes no coffee tables in a week, how much revenue is he going to get? Nothing. No revenue. He won't be able to sell any for any money. If he makes 5 coffee tables in a week, the amount of revenue he makes will be 5 lots of 120. That's how it fits in the table. The revenue equals 120 times 5. So he will make $600 in that week. And if he makes, and it asks us to draw this graph up to 9 tables, so if he makes 9 tables, the amount of revenue he makes will be 9 times 120. I've done that beforehand. Works out to be $1,080. That's the revenue. Now we'll graph that in just a moment, but we're also asked to think about the cost equation. Now it says that he hires a studio workshop which costs him $200. That's what we call a fixed cost. He must pay that $200 whether or not he makes any tables. If he makes no tables in a week, he'll still have to pay for the studio hire. Each table that he makes costs $50 as well. Now that's what we call a variable cost. It depends upon the number of tables that he makes. The more tables he makes, the more of these $50 he's going to have to pay. The cost is going to equal $50 times the number of tables that he makes. That's the variable cost per table, plus the fixed cost for studio hire of $200 per week. Let's have a look at it in the form of a table, and then we'll put them on a graph. So, if he makes no tables, the cost is still $200. Cost equals 50 times 0 plus 200. The cost will be $200. That's because he must hire that studio. If he makes, for example, and I'm just picking these numbers out, it's going to help us draw the graph. We had to draw it for up to 9 tables, so I'm going to put 3 points on the graph. In fact, you could do this with 2 points, because you know it's going to be a straight line graph, but I like to have 3 on the graph for a check. If he makes 5 tables, you can put 5 in here. 50 times 5 is 250, plus another 200 is 450. Or if he makes 9 tables, it will cost him 50 times 9, which is $450 plus another $200, $650 to make them. This revenue is the amount of money he gets from selling the tables. This cost is how much it costs him to produce tables. Let's put both lines on a graph, and we have to do it for up to 9 tables. So I'm going to make this axis the number of tables up to 9. And this axis, I'm going to put both the cost and the revenue. How far up will I have to go? Well, I'm going to look at my data tables that I've just done here and find out what the biggest number I have to put in there. With 9 tables, the revenue was 1,080. So I'll need to at least get up to there. I think if I make every square 100, so I'll just go up. I'll just mark these on, but every square is equal to 100. 2 squares equals 200. And that's fit them on, hasn't it? This is the cost and revenue in dollars. Okay, let's graph the revenue line. The point 00 is on there. The point 5600 is on there. And the point 9, 1080. That's nearly 1100, isn't it? So there's 9, 1800. Now that should be a straight line. Everything in this unit's been straight lines. And it's got the equation of a straight line. That's revenue. And we can graph the other line, the cost line. 0 200 is on the line. 5 450 is on the line. That's 500 450 is there. And 9 650 is on the graph. 650. There are 3 points. They should once again be in a straight line. That's our cost line. So we've graphed the cost equation and the revenue equation. Part C of the question says find the break-even point both graphically and algebraically. Now the break-even point is this crossover point of the graph. Excuse me. Just there. That's when revenue equals cost. It's when it's costing him as much to produce the tables as he's getting from selling the tables. And I think you can see graphically, just reading off our graph, if you get this and produce it down to this x-axis, it looks like, well, nearly 3, about 2.9. The break even occurs. .9 tables. So, if he makes 2.9 tables in a week, now assuming he can do that, he can make 2 and nearly get 1 finished. I suppose that means he's making 2.9 in a week. Assuming that happens, then his business is neither making a profit nor a loss. He's getting as much from selling them as what it's costing him to produce them. If he makes less than that, if he's operating down somewhere here making 1 or 2 tables a week, the cost is more than the revenue. The cost line is above the revenue. You don't want that to happen in business, costing you more to produce it than what you're getting from selling it. You really need to be operating up here, 5, 6, 7, 8 tables, and you will be getting more revenue than what it's costing you to produce them. Let's have a look at part C of the question. We've already started talking about the break-even occurred graphically at 2.9. It also asks us to work out that algebraically. Here's how you could go about it. we want to know when this line is equal to this line. We want to find the intersection between the two lines, and that's not difficult if you just make the two equations equal. At the break-even point, the revenue is equal to the cost. But that revenue equation was 120x. The cost equation is 50x plus 200. Now I've got a little equation which I can solve. If I shuffle that round until I get x equals something, the answer we get should be the break-even point. In other words, take 50x from both sides. 120x minus 50x will give me 70x. 70x equals 200. Now to get x by itself, that's 70 times x, so I divide both sides by 70. X equals 200 divided by 70. I'm going to do that on the calculator. And I get 2.86 coffee tables to break even. Very similar, 2.9 was what I found when I did it graphically. Okay, part D of the question says, find Jack's profit for a week where he makes 7 tables. Now to work out his profit, I need to know how much it costs him to produce them, the cost of producing 7 tables, and I need to know the revenue, the amount that he gets from selling 7 tables. But that's easily found because we've got information, an equation that can work out the cost and an equation that can work out the revenue. So with 7 tables, the revenue that he gets, the amount of money he gets from selling them, is equal to 120 times 7. And 120 times 7, I've worked out beforehand, equals $840. The cost of producing 7 tables, I can work out from this cost equation here. So it equals 50x, x equals 7. 50 times 7 plus 200. And 350 plus 200 equals 550. And to work out the profit then, the profit is the difference between revenue and cost. Profit is the difference between the amount that he makes from selling them and what it cost him to make them. So I'll just move down for a second. Should do it. His profit is equal to the revenue that he gets from selling them, take away what it cost him to produce them. So it's $840 revenue, take away 550, profit is equal to 290.